Corrosion in low-current signal wires often causes elusive faults, strange data, intermittent codes, or misleading sensor readings. This lesson walks you through a reliable approach to prove the root cause with measurements, not guesses. Low-current signal circuits operate with milliamp-level flows. Even a small corrosion spot adds resistance, causing voltage to drop or shift, especially under load. The ECU expects clear, undistorted voltages, so any drop can trigger off-range readings, plausibility mismatches, or intermittent codes, depending on when the fault appears. To prove corrosion, measure the voltage drop across the suspect portion of the signal circuit while the circuit is active. Place 1 meter lead before the suspect area and the other after it, with the sensor or circuit powered and working. A healthy joint will show nearly 0 volts. Corroded joints show voltage drop, sometimes just a few tenths, revealing unwanted resistance only under load. When odd symptoms or DTCs point to a signal issue, start with a code and data check. Then prove your suspicion with the loaded voltage drop test. If the drop appears only while the circuit is active, you've found resistance that impairs low current signaling. Follow the path. Test connections, wiring, and backs of connectors to localize the corroded point without misreading open circuit or sensor faults. Many techs check wiring with a meter and see full battery or reference voltage, assuming the circuit is perfect. But without current, corrosion causes almost no voltage drop. Only a loaded measurement reveals trouble. Don't skip this step, or you risk missing the true culprit and replacing working parts. Finding corrosion in signal circuits means thinking like the current. Test under real load, compare drop to spec, and confirm the fault before replacing any parts. This approach catches hidden resistance and saves costly guesswork, even in today's tightest low-current logic systems. Always trust loaded circuit checks, not quick continuity tests, to avoid overlooking corrosion in sensitive signal wiring. With real measurement, you'll make the right call every time.